Okay, guys, we are picking up where we left off yesterday with talking about functions, and then we're going to jump into domain and range. If I bounce back real quick, because BenQ didn't erase overnight, remember functions? If it's a function, we talked about how one value from the domain pairs with one value in the range. Okay? Talked about domain being x values, range being y values. We looked at y equals x squared. We said it's a function, right? And we talked about a couple of different reasons why. Example 2. Question for you. You look before we answer out loud. Which of the following is not a function? And if you remember what we talked about yesterday, it's pretty obvious. Which one's not a function? Which one?
Far right.
The far right? What we would call C if they were labeled. And why is this one not a function? What? Yeah, it would fail the vertical line test. If I draw a vertical line, for instance, right there, I just crossed through that function once, twice, 3 times. So right there, it fails the vertical line test, so it is not a function. Okay? So, basic ideas about functions. Now, let's go into example 3. We're going to talk about domain. And then we're going to talk about domain. So, example 3, find the domain of each of these functions. And there's a couple different ways we can look about this. Now, first of all, when we talk domain, remember we are talking about the x values. So if you know what the graph looks like, that makes it really easy. Now, I don't want to totally rely on the graph. We are going to look at the graph here in a moment. But before we get to the graph, yesterday, right here, there's a section finding the domain of a function. Okay, all polynomials have infinite domains. Okay, this one has a square root, so technically it's not a polynomial. 2 important things that when you're looking for domain, 2 important things to consider. Denominators can never equal 0, and the inside of a square root must always be greater than or equal to 0. Well, as we look at example A, do we have a denominator? No denominator, so we don't have to worry about denominator has to equal 0. What about a square root? Do we have a square root? Yes, we have a square root. And so we want to consider the fact that whatever's under the square root has to be greater than or equal to 0. And so with that in mind, what's under the square root? X plus 3. And so to make that positive, we're going to say greater than or equal to 0. So this is one way to find the domain. If you have something in a radical, set it greater than or equal to 0. Solve this. What do we get when we solve this? If you're getting x by itself, subtract 3 over, and we end up with x greater than or equal to negative 3. Okay, so what this is saying is that the domain of this function is going to be all x values that are negative 3 or larger. Okay? Now, confirmation-wise, graph this. Instead of f of x, in order to graph it, we're going to think y equals square root of x plus 3. Take a moment and graph it, because the graph is always a good friend of ours that can help us to see what's going on. What's the square root of x plus 3? Make sure your graph looks like my graph. I want you guys graphing because I want you guys practicing using the calculators, but on the flip side, I'm going to graph it also to make sure you have something to compare against. So what's this graph doing? What shape does it look like? Half a parabola on its side. Think about it. A parabola is y equals x squared. This is the square root of x. This is the inverse. And so it is. It's the graph sideways. Now, it's only half of it because it's only the positive square root. Does this make sense with x greater than or equal to negative 3? With the idea for domain, my suggestion from domain is always to read our x values from left to right. If I'm starting at the left, like I'm starting over Mr. Stanley's room here, and I'm following along, where do my x values start? Well, where does my graph start? It starts right there at the value of negative 3. And then it continues onward to the right, doesn't it? And so when we talk about domain, I'm always going to suggest that you read your x values from left to right. Because sometimes the equation is easy to use to figure out domain, sometimes the graph is easier. Kind of depends on, you know, how your brain works, really. And you can use the idea of trace, because if we just hit trace and you're trying to figure out, you can use the idea of trace to get back here and look. How far does this go back? And you'll see it's right around negative 3. At negative 3.03, my y value doesn't exist, and negative 2.87, my y value does exist. You can try finding the 0 there. There's probably a 0 there that it would let you find. But, and the fact that it's x plus 3, that just tells me my graph shifted left 3. So that's another thing too. If you see a 3 in the equation, it would make sense that that is at negative 3 there.
Oh my gosh, I learned this last year.
Huh?
I learned this.
There you go.
In Algebra 2 on grad point.
See, you thought you learned nothing on grad point.
No, this is the
learned
only
something.
thing that I learned because I had to go and get help.
Okay, there you go. Interval notation.
Here.
How do we write this in interval notation?
Negative 3 with a bracket, infinity equals.
Negative 3 to infinity. Negative 3 does have a bracket because this graph can be equal to negative 3. And it goes off to infinity. Okay. Questions on that one? Okay, let's try B. Now, in case you can't read that because it's a little squeezed in there, f of x equals the square root of x over x squared minus 25. Okay. Based on everything else I've talked about, thoughts before we go to the graph? We will go to the graph, but I don't want to go there yet. Okay. What did you say? Okay. Denominator officially cannot equal 0, right? Because we can't have a denominator of 0. Now, so how are we going to find where the denominator would equal 0? We're going to set it equal to 0. Okay, so because if you look up at number 2, denominators can never equal 0. So what do we do to find that? We're going to set the denominator equal to 0. So that's one thing right there, is I'm going to take x squared minus 25 and set it equal to 0. How do I solve? What? Oh, okay. We could factor, yes.
So it'll be the one where it's like x plus 5 and x minus 5.
Okay. So it can factor into x plus 5 and x minus 5, and I'm not against that. Was anyone else going to go a different direction? My brain went a different direction.
I just looked at it. And I was like, X was 5.
Okay, you just looked at it. What'd you say? And what was normal to you?
Add over 25 and square root.
Okay, add over the 25 and square root. Is anyone more right here? No. Okay. Could you factor this and set each part equal to 0? Yes. And that's perfectly fine too. Could you add the 25 over, which this is where my brain went. So if we add the 25 over, x squared equals 25. Now, the only problem with this one is you have to remember when we take the square root, what's the catch here?
Plus or minus.
Plus or minus.
Oh.
Now, by factoring, Kylie automatically had the plus and
You still have
minus.
plus and minus.
Huh?
You still have the plus and minus.
Yeah, but that's what I'm saying. With factoring, you automatically got it if you remembered how to factor it. Pros, cons, as long as you can get there. So, okay, now, I wrote x equals plus or minus 5 because that's what we got with solving. But what's really true, part of my domain, and this isn't going to be how we're going to write it, but x cannot equal positive 5 and negative 5. Like there will be holes, there will be asymptotes, there will be some break in the graph at positive 5 and negative 5. And so when we do our interval notation, we won't have positive 5 and negative 5 in there. Okay, what else? I don't remember if anyone said it at the beginning or not, but denominator cannot equal 0, and? Well, there is an equal sign supposed to be in there.
Well, never mind that.
It's just kind of a typo, but
You'll have that.
there's a square root. What about square roots? Square roots must be
Greater than 0.
greater than 0.
Or equal to greater equal.
And unless it's in the denominator, we always say greater than or equal to 0. So whatever's under the square root, what's under the square root? And that is, under the square root is x, so x must be greater than or equal to 0. Now, how do we put this all together into interval notation? And one of the suggestions at the top of the page says to use a number line to help you think this through. So let's think about this on a number line. So on my number line, I'm going to put a -5, I'm going to put a 0, and I'm going to put a 5, right? Those were my numbers that came up in this problem, so those are my numbers I care about. But, let's see, let me grab a different color here. X cannot equal 5 or -5, yes? So it's the idea, you can think like an X, like cross them out, or what I'm going to put for right now is I'm going to put like an open circle, like there's a hole there. Because the graph will not exist at 5 and -5. And then what's the rest of this? X must be greater than or equal to 0. So that means you're shading to the right of 0. And officially at 0, we would have a bracket, if you will. I could have used closed circle. Kind of mixing and matching here. Notice I didn't shade 5 in, though, because what did we already know? X cannot equal 5. X cannot equal -5. Does that really matter?
No, because
No, because X can't be anything negative, can it? X can only be positive values except 5. Now, I put an open circle here. Really, when we go to do interval notation, what's going to be at 5? About
I think that's what you meant
parentheses.
by the holes.
That could be. So really, we're going to think about parentheses here. So when I write my answer, okay, read left to right. When does my shading start? 0 with a bracket, comma. When does my shading stop? And we have a break at 5. 5 is not included, so we use a parenthesis. Usually I'm going to say union. So that's the U looking figure. Where does my shading start back up? 5 again with a parenthesis. When does my shading end?
Infinity.
Infinity. And infinity always uses parentheses. Now, did anyone graph this?
I just
Yeah.
did.
Yeah, it's really.
It's weird.
It's really weird.
It is weird.
Yeah.
It's like it like curves down. It's like
and
the
it breaks,
asymptotes,
and then
but
it
not.
starts up.
Asymptotes, but it's not.
So is it maybe a good thing that we used the equation to try and find domain? Okay. So as you look at that, first of all, do you see anything to the left of 0? No. Doesn't mean it's not there, but like if I hit trace here, 0, 0, it's telling me exists. As soon as I go left of 0, 0, my y's are blank. Nothing exists. So then once you get over here, you know, you kind of follow along. Notice what's happening here is there's a vertical asymptote there. That's what's happening. The calculator doesn't show it great, but right where my cursor is, this graph keeps running down and down and down. So it's the idea that it's going to go down on this side and it's going to look something like that. Okay, where it's not just stopping at like 1 or 2 above and below the y-axis. It actually infinitely goes up. The calculator just doesn't always show that well. Okay, but notice as we trace here, x at 4.8 is still down there. Then at 5, it says my graph doesn't exist. It doesn't always show that, but that's good. And then on the other side, it does exist again. So does that answer match my answer? Okay. So I'm going to tell you, domain and range are not a piece of cake. I'm trying to give you all the tips, but there's usually a little bit of challenge here with domain and range. So I'm trying to make sure we have all the details to try it. Okay. Top of the next page, we have 2 more domains, yes? C. A of S equals square root of 3 over 4 times S squared. Thoughts on the domain? What? Normally I would say X values. In this case, it's going to be what? S values. What values can we not put into this equation? Now, what were the 2 things I had you checking on the other side?
The denominator can't equal 0.
Denominator can't equal 0. Now, what's currently in the denominator? A 4. Do I have a variable in the denominator? No. So does this really apply right now? That whole denominator does not equal 0. I'm glad I wanted to talk about it, but it doesn't really apply because there's no S in the denominator. What was the other thing I was having you check?
Students, at this time, would all 8th graders please report to the gym to have your photo taken? Again, at this time, all 8th graders please report to the gym to have your photo taken. Thank you.
Next one, where is the square root?
Okay. Okay, square root. Square roots have to be positive. Greater than or equal to 0. What's under our square root? A 3. Does that rule matter this time then? No, that rule matters when there is a variable. So neither of those rules that we were talking about, the denominators and the square roots, really matter because my variable just says S squared. Are there any numbers you can't square? No, you can take any number you want and multiply it by itself, can't you? So based on this physical equation, are there any numbers we can't put in there? Okay,
Really
so
scary when we first looked at it. Now, it's
now,
not at all.
based on this equation, and there is a catch I'm going to talk about, but just looking at this equation, without thinking about what it stands for, my domain is going to be all reals, which in terms of interval notation can be written as negative infinity to positive infinity. Now, there's a but. That sounds weird to say. Okay. Shouldn't have said that. There's a catch.
We'll mature enough to handle it.
Debatable. I've learned a long time ago. Yes, says the one wearing strawberry shorts. Valid point.
I did laugh when she said that.
Okay. Now, there's a catch, is what I should have said in front of the classroom. What if I tell you this equation represents the area of a triangle with side S?
I believe it. have but.
Yes, I used the word. B-U-T. Thank you very much. So, but this models area of a triangle with side length S. Write that down, but then tell me, how does that affect my answer? It can't be all real numbers?
Can't be negative.
Oh, what can't be negative?
The area.
Area can't be negative, and can
Yeah.
side length be negative?
No.
Doesn't
No.
can't be insured.
Okay, so if you are just looking at this equation in terms of x's and y's, my domain is indeed all real numbers because I can put any variable I want in there for s. However, if I say specifically, okay, think in terms of the fact that this represents the area of a triangle with side length s, then what do you have to tell me?
Sides can't be.
Sides can't be negative, so s has to be what? Greater than 0. Could it be equal to 0?
No.
No, because then the triangle doesn't exist, right? So, all actuality for this problem, I'm going to say s greater than 0, which written in interval notation is 0 to infinity. So there's a catch on that one.
Do you have catches like that on the quiz?
I don't know. I haven't thought that far ahead.
We do.
Oh, you didn't think that far ahead.
Obviously, you guys are thinking that far ahead.
That far ahead at this point.
I'm not thinking that far ahead.
You're gonna go to just
Okay, one more domain. D. F of x is the square root of x squared plus 5 all over x. Okay, what are the pieces? Okay, so right here, denominator equal to 0. And in this case, there's no solving, is there? You set the denominator equal to 0, and what are we saying here then? Okay, so we know part of our issue is that x cannot equal 0. So if I go ahead, might be getting a little ahead of myself here, but if I think about the number line like I did earlier, if I go ahead and start thinking about my number line, one thing I know right now is that x cannot be 0. So you can think about there being a hole there, an open circle, parentheses going either way. I'm just putting a hole there to represent it. What's the other piece I need to think of? Okay, there's a square root. What do we know about a square root? X squared plus 5 has to be positive. Math speak for positive is greater than or equal to 0. Okay, are you solving?
I don't know.
Okay, so I can't go the factor route because x squared plus 5 doesn't factor. So if we go the subtract route, x squared greater than or equal to negative 5. Okay, can we square root a negative? No. Okay,
I mean,
here's the deal. Okay, can we square root a negative number and still stay in the real number category?
No.
Okay. Now, and we are just strictly talking about real numbers right now, okay?
Let's just put a real
So.
solution and call it a day.
Now, okay, go back and look at this. Think with me. If I put a positive number in for x, and I square it, and I add 5, what am I going to have? You're going to have a positive number, correct? Okay. What if I put 0 in here? Actually, 0 doesn't matter because we can't have 0 in the denominator. Okay. Forget 0. But, I mean, if you put 0 in here, 0 could work in the numerator. 0 squared is 0, plus 5. You can take the square root of 5. Okay, what happens when I put a negative number in here? Oh, you take a negative number and you square it, it's going to go positive. And then you add 5, it's just going to go more positive, if such a thing exists. So, can x squared plus 5 ever be negative? No. X squared plus 5 will never be negative, because no matter what I put in there, anytime, any number I square will always become positive. And I'm going to have a positive number, and I'm adding 5 to it. So it's going to be even more positive. It's not even absolute value. It's just the fact that this is always going to be greater than or equal to 0. And I know that because right here when I tried to take the square root of a negative, I was like, oh, wait, I can't take the square root of a negative. And so at that point, basically what we need to say is this piece is okay. You don't have to worry about it. And it's okay because it's already going to be positive. How do I want to say this? There we go. Radical is always positive. Okay, pretend I wrote positive. And it's always positive because of the x squared. Because you square an x, it's going to make it positive. You know, we'd have to think slightly different if we were subtracting 5 off, but we're adding 5, so it's all good. Okay? A little bit different, isn't it? Now, so really this, don't need to worry about that. The only thing we came up with was x cannot equal 0. Can x be negative? Yeah. Can x be positive? Yeah. X just can't be 0. So how do I write that in interval notation? Okay. Your shading starts down at negative infinity. So negative infinity is 0. 0 with a parenthesis, because it's not included. Take a break. And then 0 to infinity. Did anyone graph this one?
Yeah, it looks kind of funky.
Does it look funky again? I figured it would. I honestly don't remember what this is, so.
No, I can.
Let's get that under our square root there. Huh. Looks like a 1 over x graph is what it looks like to me. Okay, guys, does that make sense? Your graph can start all the way at the left. It's all good until it gets almost to that y-axis, and there's an asymptote happening there. So that graph is running down alongside the left side of the x-axis, or y-axis, never crossing, never touching, getting closer and closer to 0. And then on the other side, it's coming from above. It's way up there, getting closer and closer to 0, never crossing, never touching. Now, my recommendation when you go to do domain, don't just jump straight to the graph. Think about things like we're thinking about. Okay? Think about denominators. Think about square roots. Try and formulate what you think the answer might be there, but then the graph is kind of my self-checking. Does that make sense? Okay? Because as I read this graph, left to right, I'm like, okay, there's y values, we're good, we're good, we're good, we're good, all the way, we'll hit that axis, which is 0. And then same thing over here. We're good, but, so we're reading that graph from left, your left to right. Okay, let's talk range. We got 10 minutes. Can I do it? There's only 2. It just takes me a bit to explain, but, okay. Range. Now, it says here, same rules apply for range as do domain, only you solve for x first. I will say that works part of the time. I'm not convinced that's always the best way. In all honesty, I tend to look more at the graph a little bit. But on this first example, it's a good way to show the idea of if we solve for x first. Okay, so we're going to try and solve for x first, and I'll show you what happens. But like when we get down to b, I don't want to solve that mess for x. No, that's yuck. So we're just going to use the graph on b. But this one, not too bad. Now, it says f of x equals 2 over x. What's f of x? That's y equals 2 over x. Okay, if we're going to solve that for x, what do I do? If it's 2 divided by x, can we multiply by x? So if I multiply both sides by x, x times y is xy. 2 divided by x times x. Realize that is just 2. My brain wants to say solve for y, but I'm not solving for y. I'm solving for x. So how do I solve for x? Divide by y. And x is 2 over y. Now, if you use this form, think about your domain rules. What are the 2 domain rules that we've been focusing on? Square roots, denominators. Do I have a square root here? Do I have a denominator? Yeah. What's my denominator telling me? Yeah, this denominator is saying y cannot equal 0. Y cannot equal 0. Well, y, that's not domain. Y is range. Do we have anything else? No. So, have we done something like this in the past? If I think number line again, y cannot equal 0, no other restriction, so what's that mean? Can we write this like we did earlier?
Yes.
From the left is like a negative infinity. So negative infinity to 0, parenthesis, union, parenthesis, 0 to infinity. Now, if you graph this, which I'm going to, realize you graphed the original problem. My original problem was 2 over x. Don't try and graph what we solved. Graph the original problem. Yes, it looks very similar to our last problem. Okay. With that in mind, this is range, yes? When we talk range, we are no longer talking x's, we are talking y values, correct? So the difference with x values, my domain, x-axis goes left to right. So we read left to right. Where's the y-axis? It's up and down. So the y-axis, and we're not going to read left to right, because we want to read y's, not x's. So we're going to read bottom to top. Negatives to positives, right? I think, is it? Yeah. So I'm going to put up here that we're going to read bottom to top. And that's bottom to top of the graph. Okay? That's what we're going to do for range. Now, I mention this because going into this next problem, we have to understand how to read a graph. So if you look at the one that we just did, does that make sense? When you start at the bottom of the graph, does the graph exist? Yeah, it exists. It's going down here, negative infinity. Think about the y values. We're going up, we're going up, we're going up. What happens here? As we approach that x-axis, my graph heads off to the left, doesn't it? And it's going to run along that x-axis. And as it runs along that x-axis, what y value does that x-axis have? It has a y value of 0. So then you have the 0 there that's not included, and then notice it picks up on the other side. So it picks up above the 0 y value and continues up. Now, as I said, why am I kind of mentioning that? This next problem. Okay. I could consider the idea of solving this for x, but to be honest, I'm going to quickly not consider it then. Because I'm going to look at that and I'm going to be like, I don't really want to try and solve that for x. There's x squared on top, there's x squared minus 1 on bottom. No fun. So instead, we're going to graph this. And we're going to practice reading the graph from bottom to top. Okay, x squared over x squared minus 1. Kind of crazy. We have it on our calculator, and our calculator is what we need to go off of. I'm sketching it on the screen because I need to be able to point and draw on something. Does that make sense? Okay, so let's see. We have this parabola-looking dude. And okay, not exactly, but good enough. You get the idea. Okay. Now, what are we trying to find? We are trying to find range. Range is in terms of what? Y's. I'm putting that there just because it is so easy to forget and go back to domain. Okay, so where am I going to start? I'm going to start at the bottom of my graph. Where does my graph start? What is the first y value you see? No. How low does my graph go? Negative infinity? We don't have the low y value, do we? I mean, on my graph, my screen goes to negative 10. But does my graph stop at negative 10? No. These pieces right here are representing negative infinity. So where does my range start? Negative infinity. Okay. Now, I'm kind of tracing this graph up. As I trace the graph up, and it's going up on both pieces here, where's my stopping point, or my pausing point, if you will? Where do I stop? Where's this graph taking a break? And that is at the tip top of that upside down parabola, which is at 0. And that's the y value of 0, yes? So negative infinity to 0. 0 with a parenthesis or bracket?
Brackets.
Does my graph touch 0? Yes, because that is the maximum point there on the parabola. So this is actually going to be a bracket. Union. Now, this is where we want to go back to, we're going to have to go back to the calculator. We have a little gap here, right? When do my y values start back up? And here's my recommendation. Grab trace, and doesn't matter which side you go. I just happen to go to the left. And as I arrow to the left, I eventually end up on that top part. Watch, okay, my y value is sometimes in fractions. Watch the y value when it's in decimal. Hold on real quick. What's it getting closer to? I'm at 1.01, 1.01, 1.008. What am I getting closer to? 1. So what's happening here real quick, sorry, bear with me, is that there's an asymptote at 1. So my graph values are picking back up at 1. It's an asymptote. Are we ever going to touch 1?
No.
No. So parenthesis, and then how high do these graph values go? Positive infinity. Okay, guys, your homework is at 2 through 20 evens. Thank you for bearing with me an extra moment. I really appreciate it. Attempt the homework for Monday. We will talk.
Or maybe next year.
Page 94, 2 through 20 evens.
No, that's